In this recording, we are going to discuss number 12, part D, E, F, and G. Okay, so starting with D, it says use the correlation R to calculate and interpret the coefficient of determination. And the symbol for coefficient of determination is a capital R, the square on top of it. So it's R square. And it says also state whether the claim appears to be true or not and give a valid reason. So let's see where we have done that, because this is a continuation from a previous video where we have already calculated the correlation coefficient. Because say use the correlation coefficient. And we have support in week 7, page 5. So let's go to week 7, page 5 before we go to where we actually did it. Here is week 7, page 5. It talks about coefficient of determination. The coefficient of determination is calculated after you have calculated the coefficient correlation. It gives you a percentage measure of the dependent Y variable that was affected or influenced by the independent variable X. Okay. So here are the steps to calculate and interpret the coefficient of determination. It says you've got to square the coefficient correlation. So you must calculate the coefficient correlation first, square that value, then multiply this value by 100%, the squared value, and interpret your percentage value that you have gotten in step 2. So it goes as follows. The percentage of the change in the Y variable is due to the X variable. Okay, so what percentage of that change that occurred in the Y variable, what percentage of that change is due to the X variable? So the coefficient of determination gives you an idea. And here you have an example. Here it was Spearman's coefficient correlation that was squared, multiplied by 100% to give you 77.44%. And consequently, it says 77.44% of the change in score was due to hours of study. So let's see where we have done that in our example. Here, as you can see, it says Math 121B, which of course is the same content as Math 121D and A. Practice paper B, number 12. So we are in a two-variable analysis. Okay, how two variables are correlated. Okay, unlike mean, median, mode, variance, standard deviation, these are single variable analysis. But here we have two variables correlated with each other. So the objective is to determine the coefficient of determination R squared. And number 2 is to perform a linear regression analysis. So here are the steps again in a summarized form of how to calculate the coefficient of determination. You square the coefficient correlation and you multiply by 100%. And you get capital R squared, which is the coefficient of determination. And then the steps to perform a linear regression, we have to calculate the gradient and the y-intercept. So we'll talk about that after. So as you can see, our coefficient correlation was 0.86. That was the Pearson's. So here we are using the Pearson's R to calculate the coefficient of determination, capital R squared. So capital R squared, which is the coefficient of determination, is equal to 0.86 squared, that's the coefficient correlation squared, times 100%. So verify to see if you are getting 73.96%. So therefore, 73.96% of the change in the score is due to the study time, according to this data set. So now we are moving on to part E. It says to calculate the gradient and the y-intercept. Let's verify. Use the results in part C to determine the gradient and the y-intercept of the correlation of the line of best fit. Okay, so therefore now we go to week 7 to see how this can be done. And it's not week 7, it's week 8. So we've got to go to week 8 for coefficient for linear regression. So let's do that. Here we go to the table of contents, look for the content weekly notes, click on this and look for week 8. And here you have it in PDF or video format. Let's click on the PDF format. And it says linear regression. In a nutshell, linear regression is concerned with the modeling of a linear equation. Okay, so you've got to create a linear equation using the data, of course. And you can use that equation that you have created to predict and forecast future values. Okay. So now it's called least squares linear regression. And the equation of a straight line has a standard form y is equal to mx plus c. We all know that, where x and y are the related variables. X is the independent, y is the dependent, m is the gradient, and c is the y-intercept. So here it goes on to say the steps to obtain a linear equation via least squares. So to calculate the gradient m, it's not like y2 minus y1 over x2 minus x1 as geometrically. But here, using least squares, is the sum of n times the sum of xy over the sum of x time minus the sum of x times the sum of y over n times the sum of x squared minus the sum of x all squared. Though it is interesting to know that all the elements of this formula can be encountered in the product moment formula. Okay, namely numbers 1, 2, 3, and 4. Okay, now remember, we have already calculated 1 and 2, and that gives us A, 3 and 4, and that gives us B. So hence, using R is equal to A, the square root of BC, the formula for the gradient can be simplified to just A over B. Okay, because it's the same values. And the y-intercept now, here's the formula for the y-intercept C, the sum of y minus m times the sum of x over n. And once you have got the m and the c, you can complete your equation. So let's see where we have done that in our example. So here's the gradient equation for gradient again. And it's simplified to a over b, as you can clearly see. The numerator is identical and 3 and 4 are identical. And the y-intercept, sum of y minus m times the sum of x over n. Our A, in the previous session or in the previous video, you can see that A is equal to 8325 and B is equal to 2625. So you divide 8325 by 2625 to get a value of 3.17, sorry. So therefore, although it did not say to interpret the gradient, but it's could be a useful knowledge to know what the gradient means, how to interpret gradient. What does that 3.17 actually mean? So therefore, each hour, all right, each hour you study, that's the score you will obtain, or your score will increase by each hour you study. So that's what the 3.17 means. So if you just study for 1 hour, you might get 3.17. 2 hours, 2 times 3.17, okay, etc., etc. And C now is the sum of y minus m times the sum of x over n, all right, as you can see here. Right. Now we can recall the sum of y was 365 and the sum of x was 105 and n was 6. And we just calculated the gradient m, 3.17. So the numerator of 365 minus 3.17 times 105, as you can see, is 2.15, as you can verify, divided by 6 to get a C, a y-intercept of 5.36%. What does that 5.36 mean? So therefore, if your study time is 0, if you do not study at all, you will score approximately 5.36%. That is what this is saying. Okay? So if you don't study at all, you may score 5.36%. And each hour you study, your score will increase by 3.17%. Okay, so basically that constitutes There are two values that must be inserted into the equation, into the model. And here it is. Y is equal to 3.17x plus 5.36. Now here we know what is y and we know what is x. In pure maths, x and y are normally used for variables that are not really, have no particular name, all right? But here, this is applied. Y here means score and x here means hours. So your score, if you want to know what score you can achieve, that will be equal to 3.17 times the number of hours you study plus 5.36. So as we said, now we can use the model to predict and to forecast. That's what we are going to do now. So please take note, it's very interesting that you can actually use real data, collect data from individuals, their hours of study and their score. And from that data you collect from the real world, create a model, create an equation, which is an abstract concept from that real data. Okay, and here it is happening in a simplified version. Okay, so now you can use this equation now to predict, okay, to estimate, to forecast. All right, that's why data now is very is a multi-trillion-dollar company now. Is because you can use data to actually have a peek into the future, if you want to put it that way. You can actually predict what might happen with a certain level of probability. So for example, if you study for 25 hours, according to what this equation is saying, according to what the data is revealing in that context, okay, wherever the data was collected, if you study for about 25 hours, you should score about 84.61% in that exam. That's what this is saying. Okay, all factors, remain constant if you want to put it that way. So if you study for 25 hours, you put 25 into the variable hours. So that's 3.17 times 25 plus 5.36. Okay, bear in mind, each hour, your score increases by 3.17. So you study for 25, that's 25 times 3.17 plus the 5.36 you started with, okay, in the first place. So you should score approximately, let's say 85%, give and take. Now, if you want a score of 95%, about how long should you study for? All right, so you can do a little estimate of that by putting 95 in the place of score and to calculate for hours. So that's 95 equal 3.17 times hours, because that's your unknown, that's what you want to find out, plus 5.36. So you got to apply a little bit of algebra now. Okay, you cancel out 5.36, positive 5.36 by subtracting. If you subtract on the right, you've got to subtract on the left. So 95 minus 5.36 is 89.64, equal 3.17 times hours. Now to cancel out 3.17, because it's multiplying, you divide. If you divide on the right, you divide on the left. And you get a value of about 28.28 hours. So if you want a score of 95%, you should study for at least approximately 30 hours, according to what this is saying. Okay, so here is an example of linear coefficient of determination and linear regression.